Hello Math 6 students, Mr. Giomini. I promise you I'll make another video real quick. So do a couple examples here. Let's look at this first one here. So I have 5 minus 2 and 1/3. I notice there's no mixed number here. It's just a whole number. So I'm going to pretend that it's 0 zeros. Now the key to this problem is really focusing in on this thirds. So I know that I want to break this five holes up into thirds. So each hole would have a third. So I really have, let's see here. Would that be 15 thirds, because 15 divided by 3 is 5. So remember, I can't now say it's 5 3/3 because that really would make it, if I said, hey, I have 5 3/3, well, 3/3 is one whole, so that means I really have 6, which I don't, I have 5. So I need to come back over here and say, okay, I need to regroup this. Break this up. I want it to still be equal to 5, but I'm going to say, hey, you know what, now I have 4, and because this denominator tells me that it's broken into thirds, I have 4, and I have 3/3, because the 3/3 would equal one whole. And now I can subtract from that 2 and 1/3. And now denominators are the same, which is what I love to see. So I can just put that denominator here. 3 minus 1 is 2. I have 4 minus 2 is 2. I have 2 and 2/3. If I were to look at another one, let's try an addition one. I've been focusing on a lot of subtraction, which I think tends to be our biggest hang up on these. But let's try an adding one. Let's go with 7. And I'm going to have unlike denominators. 4/5 plus, let's go with 2 and 1/10. Okay, first thing I notice is I always focus on the denominators. And I say here, denominator here is 5, denominator here is 10. And I always look at the smaller one first and say, hey, can that smaller one, is that a factor of the larger one? Indeed it is. 5 is a factor of 10, so there's my common denominator. Now, our whole numbers will stay the same. So I'm just going to put an equal sign here, equal sign here. So 7 stays the same, 2 stays the same. Remember I said my common denominator, or my least common multiple for 10 and 5 is 10. Now, this is already in tenths, so guess what? That numerator just travels with us. Now I'm looking at this top fraction. What did I do to 5 to make it 10? I multiplied it by 2. Whatever I do to the denominator, I must do to the numerator. 4 times 2 is 8. Okay, now this is great. I have common denominators, so now I can just add. 8 plus 1 gives me 9. That gives me 9/10 because 8 plus 1 is 9. The denominators are 10. We don't add the denominators. And now I go 7 plus 2 is 9. I really quickly check this fraction. Can I simplify that? Well, the numerator is 1 smaller than the denominator. Whenever it's 1, the numerator is 1 less than the denominator, that means it cannot be reduced. It already is in simplest terms. Let's try a couple more here. Let's go with another subtraction. Let's go with another additional one first. Let's go with 6 and 4/5. I like the 5, I guess, today. Plus, let's go with 4 and 6. Let's go with 6. 6/7. Okay. Now, first thing I do is I'm going to look at my denominators. They are not alike, so I need to find their least common multiple. So I may start with the larger denominator, which is 7, and start counting by multiples of 7. 7. 5 is not a factor of 7. 14. 5 is not a factor of 14. 21, etc. 28, 35. 5 is a factor of 35. So there's my common denominator. It's going to be 35. Now I'm going to bring with me the whole numbers. So the 6 and the 4 do not change. The 6 will stay here. The 4 will stay here. Now I'm asking myself, what did I do to the 5 to make it a 7? Or, I'm sorry, to make it a 35. Well, I just told you. It's a 7, but I multiply by 7. So I'll multiply both numerator and denominator by 7. 5 times 7 is 35. 4 times 7 is 28. Okay, go to the next one. What did I multiply 7 by to get 35? I multiplied it by 5. 6 times 5 is 30. Okay, now I add, because this does say addition back here, so I'm making sure I'm adding. 28 plus 30 gives me, let's see, 8 plus 0 is 8 in the ones place. 2 plus 3 is 5. I'll bring my denominator down, which is 35, because they're common. I don't have to add those. 6 and 4 is 10. Now, this is an ugly looking fraction. I have a whole number with an improper. I need to convert this. Now, I already have 10 wholes. Now, I ask myself, how many times does 35 go into 58? Well, it goes in once. Well, it's one whole time, but I already have 10 holes. So I add that one extra hole. So now I have 11 holes. Add that, make sure we didn't get confused there. Now, because it only went in one time, remember the denominator travels with us, all I really have to do is, because it went one time, all I really just subtract 58 minus 35, that would give me 8 minus 5 is 3, 5 minus 3 is 2, 23 35ths. 23 is a prime number. It is not a factor of 35, so I know that is my final answer. Okay, remember again, boys and girls, you could pause this video at any time, try to answer the question, and then hit play again to see if you have it correct, rather than just sitting there listening to me blabber. And let's try another one here. Let's go with a subtraction one. Let's go with 7 and 1/2 minus 2 and 4/5. Okay. I will look for a least common multiple because I see my denominators are different, 2 and 5. I'm going to guess that, let's see here, what are my multiples of 5? 5. 2 is not a factor of 5. 10. Hey, 2 is a factor of 10, so there's my least common multiple. It is 10. So, remember the whole numbers stay the same, 7 and 2. This becomes a 10. This becomes a 10. Would I multiply that 2 by to get 10? I multiplied it by 5. So I multiplied the numerator by 5. 1 times 5 is 5. Would I multiply a 5 by to get 10? Multiplied it by 2. Multiply this by 2. 4 times 2 is 8. Uh-oh, wait a minute here. Subtracting. Red alert, red alert. I cannot subtract because I cannot take 8 away from 5. Oh no, what do I have to do? I have to regroup. Okay, this is really the same as 7 and, because we're tenths, 7 and 10 tenths. Oh, I'm sorry, this is really 7, or it's really, let's see here. Every one of these sevenths is broken up into 10. So I could really have 6 and 10 tenths, because that's the same as 7. And this could really be 2 and 8 tenths. Now here comes the tricky part. I cannot forget about this 5 tenths that I had. What could I possibly do with that 5 tenths and that 10 tenths? I just changed 7 into 6 and 10 tenths. Still we're 7, because 10 tenths is one whole. So what could I possibly do to make that 10 a little neater there? It's kind of sloppy up top. So what could I possibly do? I got to still have that 5 tenths present. Oh, I can add the 5 tenths to that, because that's the combination of the two. So now what I have, let's change back to purple again. So now what this really is 6, and denominators are the same, so it's 10. 10 plus 5 is 15. Okay, plus 2 and 8 tenths. Oh, I'm sorry, we're subtracting this. See, it's always important to revert back to or refer back to what the operation is. Sometimes I forget, and it's actually beneficial if you circle them all the time, so I might just subtract. Okay, 15 minus 8 is 7. That is 7 denominators tenths. 6 minus 2 is 4. I have 4 and 7 tenths. Okay, I hope this helps you guys out. Take care. Bye.